Today I am going to focus on the unit analysis of the physical equation, but for this I want to start with the information about fundamental and derived unit. What is fundamental unit? Units which are independent of any other unit but other units can be derived from them are known as fundamental units. For example, the unit of length, mass and time, that is meter, kilogram, second, hour, gram, etc. are fundamental units. There are many other also. Okay, what is derived unit? Units which are made by using fundamental units or which can be expressed in terms of fundamental units are known as derived units. For example, the unit of velocity, acceleration, force, etc. are derived unit. After this information, now we can start, but I want to start with certain questions because students are a little confused with the units of different derived quantities. That's why let's start with question. If you are asked like this, name a derived unit formed by using only one fundamental unit once. What it mean? One fundamental unit is used only once and a derived unit forms. It's very interesting. Look at this. This is velocity equal to frequency into wavelength. What is it? This is wave equation. Velocity of wave is equal to f means frequency and this lambda means wavelength. Now in this equation f is equal to v by lambda. F means frequency, and if we take unit of these physical quantities, then v is denoted by meter per second and lambda its unit is meter because this is wavelength. Meter cancel and we have only 1 by second. It means second to the power minus 1. This is the unit of frequency, and in the name of the scientist Hertz it is taken as Hz. But what fundamental unit is involved in it? Just second. Only once. 1 is divided by second to form Hertz. It means this is the answer of this question. What is the question? Name a derived unit formed by using only one fundamental unit once. The name of the derived unit is what? Hertz. And in this unit, second is used only once. 1 is if divided by second, then we'll have second to the power minus 1, and this is Hertz. Now let's go to another question. Why the unit Pascal is called derived unit? What is Pascal? It is a unit of pressure. Pressure equal to force by area, and when unit of force and area are taken in right hand side, then we'll have Newton per square meter because Newton is the unit of force and area its unit is meter square. And if we take the expanded form of Newton, it is kg meter per second square. If meter cancel, then we'll have kg divided by second square and is divided by meter. It means we have lastly kg meter to the power minus 1 second to the power minus 2. This is Pascal. Therefore Pascal is made by the unit of fundamental unit kilogram, meter and second. Hence it is a derived unit. We can write like this. Okay, let's go through another question also. Find the fundamental unit involved in the unit of potential difference. If this is a question, then we can do like this. Unit of potential difference is volt. We know this. Potential difference is equal to work done by charge. What it mean? The total work done between 2 points of a circuit by the flow of 1 coulomb charge is called potential difference between those 2 points. Or we can say potential difference is equal to energy conversion instead of work, energy conversion upon charge. It means what amount of electrical energy converts to another form of energy between those 2 points when one unit charge flows from one point to another. This way potential difference equal to work done by charge, and it can be denoted by this way symbolically. Potential difference or voltage is equal to work done by charge Q. Now here something is a little different. Look at this Q. If we take the unit of Q, I mean to say charge, then we have to write coulomb. But coulomb is not the fundamental unit. That's why I want to change this Q with I into T. That's why I am writing work done the same and current into time. This way we can give reason also because Q equal to I into T. When units are taken in both the sides, unit of this voltage or potential difference is volt, and unit of work is joule, unit of current is ampere, and unit of time is second. This V represents potential difference or voltage, but this V represents its unit volt. Okay, now we can expand this joule. Joule is Newton meter, and Newton is again expanded kg meter per second square, and meter is already there upon A into S. Now finally we have kg meter square second to the power minus 3 current ampere to the power minus 1, because this second is in denominator and these 2 seconds are in denominator. That's why if it is taken to numerator, minus 3 meter square is in numerator, it is in numerator, and current is in denominator, I mean to say ampere is in denominator, that's why it is taken as minus 1. These are the fundamental units involved in volt. That's why what can we write? The fundamental units involved in the unit potential difference, that is taken as volt, are kilogram, meter, second and ampere. Kilogram, meter, second and ampere. If you are asked how many times the meter is involved or how many times second is involved, you can write this also. Okay, now I want to tell you something other than this. Dimensions of physical world. Actually there are 7 dimensions. All the physical quantities can be expressed in terms of fundamental quantities, which are known as dimensions of the physical world. There are 7 fundamental quantities, so there are 7 dimensions in the physical world. They are length, mass, time, electric current, luminous intensity and amount of substance. These are the physical quantities and they are fundamental physical quantities, but all the other derived quantities or all the other physical quantities can be expressed in terms of these physical quantity, I mean to say fundamental quantities, and they are named as dimension. Okay, let's talk about dimensional formula and dimensional equation. What it mean? Dimensional formula. Physical quantities expressed in terms of dimensions of the fundamental quantity is called dimensional formula. Just for example, we know that the unit of velocity is meter per second. Here, unit of length is involved, unit of time is involved. In dimensional formula, we are related to length, mass, time, temperature, etc. And that's why how many times this length is involved here? 1. And how many times time is involved here? Once. And that's why we can write this dimensional formula of velocity like this. Length is involved once in this unit of velocity, and mass is not involved, that's why mass is involved 0 times, and time is involved once, but it is in denominator. It means length is divided by time. This is represented by dimensional formula. This is the dimensional formula of velocity. But dimensional equation means what? Equations which express the physical quantities in terms of dimensional formula is called dimensional equation. What it mean? Dimensional equation of velocity will be V left hand side. Equation means we must have left hand side and right hand side, both the sides. In left hand side we have V, which should be taken into the big bracket, and in right hand side length, mass and time should be written, and this is here dimensional formula, and dimensional formula is this, but the dimensional equation represents both the side. This is dimensional equation of velocity. This way we can understand dimensional formula and dimensional equation. But I want to tell you about the principle of homogeneity. Homogeneity means in any equation left hand side is equal to right hand side, but this word is designed for dimensional equation. So according to the principle of homogeneity, dimensions of each of the term of the dimensional equation on both sides should be same. In left hand side, what is the dimensional formula? The right hand side should be the same. That's why principle of homogeneity can be used for different purpose. It is mainly used for the unit analysis. Okay, unit analysis of the equation. If we have to analyze whether this equation is correct or not, v equal to u plus at, we can do this way. Left hand side, here left hand side is equal to v. And if the unit of v is taken, then left hand side will be meter per second, equation number 1. And right hand side is u plus at. If its unit u meter per second square, time is second. And if we multiply these two, then 1 of the second is removed, meter per second plus meter per second. And in unit analysis, we are not concerned with the number because we are looking at the unit of left hand side and looking at the unit of right hand side. They are equal or not. If they are equal, then we can say that this equation is correct. So in this case, meter per second plus meter per second is not written as 2 meter per second, but the meter per second only, because we are not concerned with the number. Okay, this is equation number 2. In equation 1, we got meter per second. In equation 2 also we have meter per second. That's why from equation 1 and 2, we can say left hand side is equal to right hand side. So this equation is correct. Fundamental units on both the sides are same. So the equation is correct. This way, analysis of the unit gives us the idea whether the equation is correct or not. Okay, let's go to another one. Analyze the equation kinetic energy is equal to half m square v, whether this equation is correct or not. How can we do this? First, we have to say left hand side equal to kinetic energy. And what is the unit of kinetic energy? Unit of energy is joule, whether it is kinetic energy or sound energy or light energy or any other energy. So we can write left hand side joule. And this is equal to Newton into meter. We are expanding joule into Newton into meter. And Newton can be expanded again, kg meter per second square, and meter is already there. And it is kg meter square second to the power minus 2. This meter and meter multiplies and it is in numerator, and second square is in denominator. That's why it is taken to numerator and power is negative. Okay, now we can say that therefore left hand side is kg meter square second to the power minus 2. This is equation number 1. Now we have to go through right hand side. Right hand side is half m square v is given here. So I am writing the same. But half doesn't have any meaning because we are just talking about the unit, whether the same unit is present in both the sides. The fundamental units on both the sides are same or not. And that's why we are not taking half. When unit is taken, right hand side, we have mass square, it means kg square, and here we have velocity meter per second. Now finally what we get, kg square into meter to the power 1 second to the power minus 1. When second is taken to numerator, then its power becomes negative. Okay, now compare left hand side and right hand side. Kg meter square second to the power minus 2. Here kg square meter to the power 1 second to the power minus 1. They are completely different. That's why left hand side from equation 1 and 2, left hand side and right hand side are not equal. So this equation is not correct. Fundamental units on both the sides are not same. So the equation is incorrect. This way we can declare whether the given physical equation is correct or not by the unit analysis. Okay, let's go to next. What are the advantages of unit analysis of the equation? Now these are the advantages. Number 1, to prove the accuracy of the physical equation. Whether the equation is correct or not, we can prove by using unit analysis. So this is one of the advantages which we have done just before this. Now next, to relate different physical quantities. We are relating different physical quantities. Power is related to work and work is related to force also. This we are doing in the process. Now third, to find the dimensions of new physical quantity. I want to give example. Fundamental units of gravitational constant. Gravitational constant is new physical quantity. The equation given by the Newton's law of gravitation. Okay, fundamental units of gravitational constant, we have to find the units involved in this gravitational constant. First, I want to tell you what is gravitation, and then we can go through gravitational constant. Let's say there are two masses, one is m1, another is m2, and they are at a distance of d. Then what is the gravitational force between them? Certainly they attract each other. This force of attraction between them is gravitation, and it is given by F equal to G m1 m2 by d square by Newton. Here F means gravitational force, m1 m2 are these masses, and d is the distance between them from center to center. But what is G? Capital G is gravitational constant. This is new physical quantity. Now I want to write G equal to what? If d square is taken to left hand side, we'll have fd square. m1 m2 is if taken to left hand side, then we'll have fd square upon m1 m2. We can write G equal to fd square upon m1 and m2. And if we take their units, force, it is measured in Newton, and this distance is measured in meter, d square means meter square, and m1 and m2 both are masses. And if we multiply kg with kg, then we'll have kg square in denominator, but in numerator Newton is expanded to kg meter per second square. This meter square is already present in numerator. And if we go through the process, I mean to say is this kg is cancelled with one of the kg from denominator, and meter square multiplies meter, then we'll have meter upon second square into meter square in numerator, and in denominator kg, and therefore G is equal to meter to the power 3, kg to the power -1, second to the power -2. What it means? In the unit of gravitational constant, meter involves thrice, which is divided once by kilogram and 2 times by second. Okay, now let's go to another point also. To convert the unit of one system into another. What is it? How can we convert? Let's take example. Convert Newton into C.G.S system. If you are told like this, you can say like this. We know Newton is equal to kg meter per second square. But in this case, in place of kg, we are using gram in C.G.S system. Instead of meter, we are using centimeter, but second is same in both the system, C.G.S system and SI system. That's why we have to write this matter. Mass, displacement and time are measured in gram, centimeter and second respectively in C.G.S system. So the unit of force will be gram centimeter per second square in C.G.S system, which is called dyne. This way we can convert one system of measurement into another system of measurement. Okay, why don't we do one conversion? I want to present one conversion. Now, if you are told to convert 1 Newton into C.G.S system, then how do you convert this? 1 Newton is equal to 1 kg into 1 meter per second square, we know. And if we put the value, then we'll get 1 kilogram is equal to 1000 gram, 1 meter equal to 100 centimeter is 100 centimeter, and if we multiply them, then we'll have 1 having 1 lakh gram centimeter per second square, which can be written as 10 to the power 5 gram centimeter per second square. But we know that gram centimeter per second square is dyne, and the symbol is dyn. So 1 Newton is equal to 10 to the power 5 dyne, or 1 lakh dyne. This way we can convert unit of one system into another system. There are some limitations of unit analysis of equation. We can say, number 1, constant of physical equation cannot be found. We are not doing anything about the number. Number are not touched. Number cannot be expressed. Constant cannot be found by this unit analysis. Number 2, an equation may be correct in the unit analysis but may not be correct scientifically. What it mean? I want to give example. Let's say b square equal to u square plus 2as. You know this. This is one of the equation of motion. If 2as is taken to left hand side, we will have v square minus 2as equal to u square. Okay, let's write like this. U square equal to v square minus 2as. This equation is correct according to the equation of motion. But By mistake, if we write u square equal to v square plus 2as instead of minus, then if we check this using the unit analysis, left hand side will be u square. We can write meter per second whole square. This is equal to meter square by second square. And in right hand side, v square plus 2as. V square means meter per second whole square plus 2 is constant, that's why not taken. Meter per second square is the unit of acceleration and s is displacement, its unit is meter. And now we'll get this meter square by second square as a result of this square. Here in numerator, meter into meter is meter square, and in denominator second square. Now what is the result? Meter square upon second square plus meter square upon second square. We will not write 2 meter square by second square because we are not talking about the number, we are talking about only units. That's why the result is meter square by second square. Now right hand side and left hand side are same. This is equal to this. We can write LHS equal to RHS, but do you think this equation is correct? This equation is incorrect. If we use this equation to solve numerical problem, then we'll get another answer. Actually, the numerical problem wouldn't be correct. An answer wouldn't be correct. Scientifically, this is incorrect equation, but by the unit analysis, it seems to be correct. So this point is written, an equation may be correct in the unit analysis but may not be correct scientifically. Okay, let's go to another limitation. Unit analysis is useful in the multiplication and division process but not in the addition and subtraction process. Just before this, I told you about the subtraction and multiplication. Instead of plus, if minus comes, it won't say anything correctly. Okay, now next, it does not give any important information about dimensional constant. Just for example, gravitational constant. We found the fundamental units involved in the gravitational constant, but it doesn't say that it is the force of attraction between two unit masses separated by a unit distance. That's why we cannot get important information about the dimensional constant. Lastly, I want to use the unit analysis for the analysis of another important equation. This is P equal to I into B. If you are told prove that P equal to I into B is a correct equation, then how can you prove? You have to take left hand side and right hand side. Here left hand side equal to power. Power equal to current into voltage. And what is the unit of power? It is watt. That's why left hand side equal to watt. And watt is expanded form is joule per second. And expanded form of joule is Newton meter. And expanded form of Newton is kg meter per second square. Into meter is already there and upon second is already there. And finally we'll get what? Left hand side kg meter square second to the power minus 3. Now right hand side I into V, current into voltage. I is same but V is W by Q, work done by charge, because V equal to W by Q. But here I want to say something. I is equal to Q by T, rate of flow of charge, and Q equal to I into T. So I want to replace this Q with I into T because unit of charge is coulomb and coulomb is not fundamental unit. That's why I want to replace with these two physical quantity. I can write I into W by I into T, and I cancel. We'll have now W by T only. W by T means work done by time. Work done can be expanded as Newton into meter, and time is represented by second, and kg meter per second square is the expanded form of Newton, and there is meter already present in numerator, and in denominator we have second. Now finally we will get what? Kg meter square second to the power minus 3. Now compare left hand side and right hand side. Left hand side kg meter square second to the power minus 3, right hand side also the same. That's why we can say from equation 1 and 2, left hand side is equal to right hand side. So we can declare that this equation is correct. It is told correct in the question also, but we have to prove. Fundamental units on both the sides are same, so the equation is correct. Now this was the unit analysis. I think it is very helpful to you. Now I want to stop this class because it is being longer and longer, so we'll meet in next class. Okay, thank you.